Hello, this is the fourth video of the first sequence and series section on summing series for OCR Pure Core Further Mathematics. In this video we will use the standard formula for r squared and r cubed to find combined sums. So we can use the standard formula to work out the sums of polynomial expressions in R by splitting the expressions up into the components as shown. So I'm going to take that 3 out again for summing the R. And one of the key things is not to forget that you actually do need to sum the ones and use that result. So for example here, you know that you're going to be using n times n plus 1 times 2n plus 1 all over 6, the standard result for r squared, plus then 3 times 50 times 51 over 2, so using the standard result for r, and that you know you're going to have a plus 50 because the standard result for sum. When you add all that up on your calculator, you get that result 46,800. If you're asked for a general expression, again you would split up those terms. So you've got that general expression for r squared, which is n plus 1, 2n plus 1 over 6, given you don't know what n is. And then you're going to have 3 lots of the general expression for r, plus of course your n, because you've summed the 1. So if you decide to manipulate that algebraically, I'm going to take out a factor of n by 6 and then look at what's left, and I get 2n squared plus 3n plus 1 from multiples, and then obviously I've had to adjust the multiples to get the 9n plus 9 from the n times n plus 1 3 over 2 factor, and then I've just obviously got a 6 from that last n. Carrying on, doing a little bit of algebra, that would give me 2n squared plus 12n plus 16, and if I cancel down by a factor of 2 and factorise, that leaves me with n over 3 n plus 2 times n plus 4. And that gives me then my general expression for summing that polynomial. If I had an expression that involved the sum of r cubed, I could of course go about the question in a similar way, but using the formula for r cubed. So sometimes we notice that the sums don't start at r equal 1. So here we have it starting at r equal 10. So I think the easiest way of going about that is to consider what it would be. We can work out what it would be for that by splitting that up, and then just, I'll put a bracket around that to make it easier, subtracting the bit we don't want. In other words, r is 1 to 9 of the same thing. So in this example then, we would find that we had 40 times 41 times 81 over 6 minus 40 for that first bit from 1 to 40, and then we're going to subtract, and noticing that n is 9 now, 9 times 10 times 19 over 6 minus 9, and we can use our calculators to get the result for that. Again, clearly if we had an r, summing any r terms or r cubed terms, we'd go about doing it in the same way, using the standard formula for r, summing r and summing r cubed. In the next video we will look at the method of differences.